Okay, let's get started. So today we're going to be talking about Numpy arrays, another data type in Python that's really useful and really important. Before we do that, I uploaded the demo to the page for today on B courses. So please download it if you can, if you want to, because there's like a lot of writing on there that you might need. It might take a while to type it all down. So on the B courses page for today's lecture, Numpy arrays, at the very bottom, there should be a link to the demo. Okay. So announcements, homework 4 is due tonight, and homework 5 has been released and will be due next week. So I have my office hour today, so if you need help, you can come there. And that's today's announcements. There's one more announcement, actually, I lied. Final project. So if you guys read through the syllabus, we did mention there'd be a final project for this class. It's required to pass the course. So we released like a spec and some information on the final project. So I can go through that right now. So if you go to B courses in files, final project, and this first file, this is like the project spec. Basically, you'll be combining everything that you've learned and you will learn this semester into your final project. It's 1 to 2 people per project. We won't accept more than 2 people because it is a project that you can and should be able to do by yourself. So please keep that in mind. If you have somebody you want to work with, that's perfectly fine, but no more than 2 people. Basically, our criteria right now probably won't make that much sense right now, but in a couple of weeks, once you guys learn all the material, you'll be able to do all of this. Basically, you take some data, clean it, fix it up, make it look nice, and then make like a model to match your data. That's just like a very quick and easy rundown of it. But in the next couple of weeks, like starting today's lecture and like the following weeks, you'll be using like all of these topics that we teach you about. Highly recommend you make a new repository for your project, just so like if you guys want to show it to for a research or a job interview or anything like that, it's really easy to like just show, okay, this is my repo for this project where I did all of these things. So that's one thing. There are 3 parts to your final project. The first is your proposal. So your proposal is going to be due in 2 weeks. I think I set it as March 15th, and that's the Friday. It's a Friday, and it'll be due in 2 weeks from now, or 2.5 weeks. So that's when your proposal is due. Basically, in your proposal, you're going to write how you'll complete these first 4 items in your criteria, like how you're going to get your data, like where you're getting your data from, how you'll be like filtering the data, cleaning it up, and then how you like match your model to your data. And make sure your proposals are very detailed. Don't make them like a paragraph. The more detailed it is, the more like we'll understand what you're doing. So if you don't understand, then it seems like we're not really sure what you're doing with your project. So really make sure that you have data and that you really know what you're doing with the project. It just makes it so much easier towards the end, and start as early as you can, like as soon as possible, because it's not as easy as it may sound and may look just based on like what we teach you in class. Working with data does take a long time and it can be really annoying. So try to start as early as you can and as early as like we teach you how to do these things. And then the second part is the actual project where you'll actually be doing your coding and everything. So Most of you will probably do it in Jupyter Notebook just because it'll be a little bit easier to see everything because we will make you do like data visualizations and all of that. So that's where you'll be putting your project. And then finally, we have a report that we want you to write, just 2 to 3 pages. And it'll basically be pretty much everything that you put in your proposal, but more fleshed out and more concrete because it'll be after you have already finished your project. So like talk about changes you've made and all of that. I think I also put a spec for the report up as well. And then your timeline. So today we introduced the project. In 2.5 weeks, your proposals are due. And then the last 2 lectures for the semester are work days and class work days. Highly, highly, highly recommend you guys come to those and ask us questions because you will have questions. Highly recommend you come there so you can ask us for help outside of office hours. And then on April 26th is when your project is due. That's the last day of classes, the Friday, before RR week. We might extend the due date just depending on how students are doing, but just for now, like plan to have your project done by this date. We'll also upload like a sample project and like a sample proposal so you guys have a better idea. If you have a final project idea that's not like this, not what we want you guys to do, you guys can always ask us, like post on ad or email any of us and ask if this is like a good enough project and all of that. Okay, are there any questions on the final project or just questions in general? Okay, if not, we'll jump into arrays. You can always read the spec on your own time and ask questions on ed. Oh, also I uploaded a research resource that one of our former instructors made. It's basically like how to find research or how to find data and all of that. There are a lot of websites and resources here. All right. So now we'll talk about NumPy. Before we talk about NumPy, I'll go into the NumPy documentation. So the end of the slides. There's like this website for NumPy. Basically, it has like every NumPy function that you can use. It's so useful. You will always use it like forever. As long as you work with Python, you'll always use it. But this like absolute basics guide is really nice because it shows you a lot of different things you can do with NumPy just like as a beginner. So it'll talk about like installing and like importing, like reading code, and has all of these things in there. So if you ever get stuck, this is like a good resource to start with, especially with homework. And especially for this section, looking things up is really important. But just make sure that like you're citing and you really understand what's happening, like you know what the function is doing, you're reading the documentation and all of that. Okay, so we'll start with talking about installing and importing NumPy. So how about you guys do this right now? Because sometimes you might run into issues. In your terminal, run either of these lines, pip install NumPy or conda install NumPy. This will just allow you to use NumPy in VS Code. Unfortunately, you have to install it, which is annoying, but yeah, do this right now while I talk about the rest of this. When you use NumPy, it's like a module in Python. it's not built into Python, so you have to import it at the top of every file. So whether you're working in VS Code or Jupyter Notebook, you always have to include the line import numpy, and you can say like as np, which is an alias, just so you don't have to write like numpy all the time. And you use this to call numpy functions. So an example, if you want to take the square root of an array or anything, you can use np dot square root of x. Okay, so the big thing about NumPy is that you get to use data types called arrays, and they're like the best data type you can work with in Python, in my opinion. But why are they so nice? They're like lists, but they're so much more better. So when you initialize an array, we have parentheses, and then you have to include your brackets inside. Don't forget the brackets, because otherwise it'll get mad at you. So don't be like me and forget the brackets. They can store any data type like a list, and you can use the same operations as a list. But there are some key differences. So we'll talk about this difference. What happens when you add two lists? Anyone remember? Yeah. Yeah. So when you add two lists, you're basically concatenating them. So if I added these two, let's say they're lists, 1, 2, 3, and 2, 4, 6. If you added them together, you would get the list that's 1, 2, 3, 2, 4, 6. Does anyone know or have any ideas what would happen if you added two arrays that were like 1, 2, 3, and 2, 4, 6? Yeah.
So you would add comments.
Yeah. So it would add each corresponding item together. So it would do 1 plus 2, 2 plus 4, 3 plus 6. So your output array would be 3, 6, 9. So that's a lot more useful than just putting them together, because there's so many different functions that will concatenate and append lists together. But being able to add two vectors is really nice. And yeah. So arrays are basically really similar to matrices and vectors. If you haven't heard of them before, that's perfectly fine. But you can consider them like matrices and vectors. So there are more operations with arrays. So I just showed you that, or you just found out that adding and subtracting them will add the components together. Multiplying and dividing by scalars will do the same thing. So if you multiply an array by 2, all the corresponding values will be multiplied by 2. Or if you divide by 2, same thing. All right, let's show it to you in code now. So, yeah.
Okay, so in VS Code, like Megan said, you're going to want to have import numpy as np at the very top. Otherwise, your code won't know what you're referencing. So you have to include it in every time you have a new file at the typically they're put at the very top. So that way all your code underneath can call upon it. Okay, so let's say we want to add two lists together, and I'm going to call this one list. How would I add these together? Any ideas? Well, what do we know it's gonna do if I add list 1 to list 2? Everyone's so quiet. Yes. Yeah. Yeah, so how would I do that? How do I add them together? So these are lists. We're not working with arrays yet. So we're thinking back to a few lectures ago, or yeah. Yes, but there's a much simpler way.
Like actually adding them.
Yeah, how can I concatenate them? You know? You want to try? Yep, so I can just go, I can even go like this. Whoops. And then I can go, oh my goodness. And now I've concatenated them. Did everyone see how I did that? Okay, there's another way you can do it that I don't know if we've gone over this notation, but you can also write, if you include this little F statement, then you can, it's a new way of formatting your print, and it allows you to basically put in a variable inside your print statement. So if I want to say like adding to lists, then I can use curly brackets and I can go list 1 plus list 2. And that'll give me the same thing. So I basically took whatever list 3 was, and instead of writing list 3, I used curly brackets and I added them together all in one go. Are there any questions? Yes.
Do you have to put that entire phrase adding to lists, or could you just use?
No, I could, you can completely just, same thing. It's just like, I was just writing it out to show you that you can combine a string with the variable if you use the F. Yeah. You have a question? Yeah, of course. Yeah.
It's not gonna save it.
Like, yeah, so it won't, yeah, so you're not calling a new variable. There's like here with list 3, I can, that'll be like saved later on. So I want to call upon list 3, I would have 1, 2, 3, 4, 5, 6. But if I'm just printing out, oh, what's list 1 plus list 2? Yeah, it doesn't save it. Okay, now we're gonna add 2 arrays together. So for an array, I have to call numpy. Otherwise, Python doesn't know it's an array. So to do this, I'm going to specify np, just like the np.square you saw in the slides. So I'm calling upon numpy, and then I'm going to call it an array. So this is what I want numpy to be doing. I want it to be creating an array, which is kind of like a function. So I'm kind of calling a mini function here. So then I'm going to have 2 parentheses, just like a function, but I'm going to define an array inside that function. So I'm going to call this 1, 2, 3. Okay, and now I'm going to make one more array. And I'm going to follow the same steps. So I'm going to go np for numpy. And then I want it to use the function array. So I want to turn these numbers into an array. Parentheses. And then inside that, I'm going to go 4, 5, 6. Okay, how do we think we can add 2 arrays together? They're just like variables, just like lists. They're almost identical. So are there any guesses?
Since we put it up there, just, where you can close it down to.
Yep, we can do just that. Wait, I think I need to call this an array. There we go. Okay. All right. So yeah, so you can just add arrays by just same as you add lists. So list 1 plus list 2 equals list 3. Array 1 plus array 2 equals array 3. And I can follow the same format that I did above. So I can do print. And then I can do the F format. And I can do adding two arrays. And then I can do my curly brackets again. And I can do array 1 plus array 2. And I get the same thing. Are there any questions?
Oh, also, if anyone's having any issues with like the pip install Numpy, just put a hand up and we'll walk around. I figured if you're a Windows user, you might as well have it.
Is it not working?
If you're having issues with NumPy, try this. If you're on Mac, Command Shift P. If you're on Windows, Control Shift P. And search this up and select either the base or Conda environment.
See, I tried that. And it didn't work for me. Really? I had to but pip also was installed on my computer, so but it could be something different.
Yeah, usually they change the environment.
Yeah. Is it about here or is it about? Yeah. So arrays, so do you know how vectors, do you know what a vector? Yeah. So when you have a vector, you have vector, it's in the x direction, it's 1x and then it's 1y. So if you add two vectors together, you kind of create a projection. Yeah, so you can create a bigger one. So you're basically adding the components together. It's the same thing with arrays. So you can't really concatenate the vectors. You can kind of just add their components together. Yeah. Or is it about, okay. Yeah. Yes. Yeah, so you can do dot product too. So, but this is just very low, just basic, yeah. But you can Google it. You can let me know. I forget how to do dot product. You have a question about? Yeah. Yes. Well, I don't so when I download, yes, we all have to do the top 90 file. This is for not five. Okay. Right. So that's all. So, let's say I was, let's say I wanted to yeah, okay, so let's say you want to change her.
So just change your environment.
Yeah. Then let's say I.
What's the, yeah, I know yours is but if you just do pip installing your. That's what especially if I do in the base.
also do it outside. Oh, you should be opening number. It's not Numpy like download, it's gonna be way to important ones. But it shows up in green when it's sometime. Well, that's because of the Facebook and so you're also important. Where is it? You can also, you can import anything that this way. Plus, oh.
But if it's right for, I think, but then you have to enter. So now in the terminal, instead of doing Unix command, like say Python 3, you can type Python. But
Okay.
Python
I
3,
don't know where the code line. I can remind you. I'm so sorry. Manual. It should be the right one, so I don't know.
whenever you have those three.
But I think I should write it.
Right.
So, yeah, I'm typing right now. Yeah. What did you read?
Just like that.
File and re-existed. Awesome. Thank you. Yeah, this is what kind of.
Right.
So you're just basically filling it, it's just, it's not. So that
So do we have to?
Yeah, you can just use this one, you don't need to create it. So then we have this.
Where's that file? The second page?
You have to know everything.
I've missed.
Tab marked in. So it's like defined in here, so then. Is the file on view? So then you need. Oh, it's on the page, it's on me. Pages, so it's all, so everything needs to be in, and then you can go to today, this is all promise. That raise, yeah. Everything is about. Then another one here.
Yeah.
Right. So number arrays are not really, so now you create functions, so you have to like put like the variables, yeah, kind of like that. So basically, you're on the inputs into your functions. Not really. So we define a function like, we call it like one, like parentheses, one, two. And we write all the functions and add them together to set that three. So in this case, instead of like writing a whole function to turn that list into an array, I'm just calling them that up.
Oh.
So it's kind of one function. In one. So you have to call entity dot array. Yeah, but there's entity dot hundreds of things. Oh, Megan tried another one that's dot first one. Yes. So you have to import that. So call this one. What is it? How did you install?
What, like in?
Yeah.
Oh, like, oh, you can't throw the yard. That was all that.
Yeah, okay.
I tried and said this already installed.
Oh. Maybe better than
Okay, so if you still have issues, just raise your hand and one of us will come, but we need to continue the lecture. So. Okay, so now we know that there are different ways to use arrays and how they're different from lists. And like, how does this make them more powerful? So the biggest way is that a lot of the things that we use loops for, you can just find a numpy command to use instead. So for example, taking the sum of the numbers 1 through 100. There's a way to do it for loops, and there's a way to do it with arrays. So I want you guys to, or I don't know if we have enough time for this, but we can do this together, write a for loop for it, and I'll have you guys help me write it for arrays. So Brianna, you do this one. Yeah. So do you guys remember how to use a for loop to take the sum of the numbers from 0 to 100? Take the sum of the numbers in general. Anyone want to tell Brianna what to write?
Well, I need to bring 0 to 1 to 101. And then, or just like define a variable for that, I guess. That plus equals 100.
Close. I would actually use a for loop. Because it's not conditional. Yeah. But yeah, so and then what's the next statement you want to write?
Well, I would define a variable for.
Okay. What variable?
Sum.
Why 0?
Just like start. And then any of sum plus.
Okay. And then
Right, sum.
print.
This is a function.
Return sum.
And would I put it here or would I put it outside the for loop? Why would I want to do it outside?
Because you can't.
What I wanted. And then I can call. Yep. Good job. All right.
So now for arrays, I want you guys to look up how to sum numbers in an array. Something like that. And like the first thing that comes up should be like numpy dot sum name. and tell me what you guys get. Or what function comes up.
Can I like zoom out by like 1 so I can hold the whole function?
Um,
Or is there a way to like decrease
you
something?
can, but then it's hard to see in the back.
Okay, because I just like can't show. As
know.
I can just show this.
Anyone find a function? Even if you're not sure, that's okay. Yeah. There's a function called numpy.sum that'll, and what does it do?
Sums of all the elements.
Yeah, so if you have an array and we pass it into this function numpy.sum, it'll take the sum of all the elements in our array. So how can we use this function to take the sum of all the numbers from, I think it's 0 to 100? Yeah. Any ideas? Yeah.
Would you put an array in there, 1 to 2, or 1 to 100?
Yeah. So
Do you want me to write out a whole array from 1 to 100?
we don't want to write an array from 1 to 100. We don't want to write the np.array and like 1, 2, 3 all the way to 100. So now there's another function we have to look up. How do we make an array of numbers from like 1 to 100? There's a function to do that. Somebody can find the function. There are a couple of functions. Yeah. Yeah. So it's really similar to the range function that we used in like our for loops. So numpy.arange. If you actually look up arange in,
Do you have Google?
oh yeah.
Oh. Just look it up. Or do you want to look it up?
Or yeah, I can look up. So if we search up numpy.arange. So our first parameter is a starting value, then we have a stop value, and we have a step. So what would our starting value be? We want to make an array from 0 to 100. Yeah. Then what about our stop? Yeah, 101. So if you look at here, it tells you that it does not include the stop value. So we have to do to 101. We don't need a step here because we just want it to be like incrementally by 1.
Okay, so what would I put inside np.arrange? So we actually don't need to write an array inside. We just need to give it a value.
Oh, they put the brackets in the documentation to show that that value is included. Yeah, that's why it's there.
So 101.
Yep. Yes.
What's that starting one? Does it automatically do that?
So we want to start, so it starts at 0.
Oh, got it. Okay.
Yeah. So if we wanted to start at 50, we could write
Mhm.
Yeah, and let's say we only wanted to do like, we wanted to jump by threes, I could do it like this. So that would do numbers 50 to 100 to 100, skipping by threes. But that's not what we want to do.
You don't have to include the 0 as you're starting because it just assumes that you're starting at 0 when it's written like this way.
Yeah.
Everything in Python starts at 0. So, okay. Yeah, it's just like part of this function. If you don't input a start, it'll just assume you're starting at 0.
I mean, you could technically like write this, but you're not providing any extra information.
Okay, so how can we complete this function?
You just take the whole.
Yeah. So we can copy and paste the previous line and put it into our sum. What might be a little bit easier would be to set it equal to some variable and plug that in. That's what's easier to see. And we're missing one more thing for a function.
Or we can just,
We can assign it to a variable or we can just return this. Either way, that's easy for you guys to read. Works.
and then we can check to see if it worked by calling our function. Yep, then we get the same answer.
And that was all in one line. NumPy this way is like a lot faster than using a for loop. Although like it didn't really look like it. They both pretty much ran what looks like at the same time, but NumPy will always be faster than using like for loops. So always try to use NumPy arrays when you can and NumPy functions. I'm not sure if we'll get to everything, but I'll try. These are some other functions, as like examples, like you can take the mean of an array, find the median, the standard deviation. Like there are like so many different functions, so many different uses. You'll like not be able to touch on all of them. You'll just encounter them as you go. So now we talk about arrays and slicing, our 2D arrays and slicing, which is like the biggest pain of this class, I would say. My biggest pain when I took this class. So 2D arrays are basically matrices. They look like this when you make one. So you start off with your basic input. So np.array, your parentheses, then your brackets. And then you input multiple arrays in there. So each array you input is one row. So this was my first array, 1, 2. That was my first row. And then my next input was 3, 4, which is my second row. These are indexed slightly differently than like lists and regular 1D arrays. These ones can be a little bit more challenging to think about and to conceptualize, but hopefully like after this lecture and after discussion next week, it's a lot easier to understand. So when we want to index into a 2D array, we put our brackets, and then if we want a specific value, we put the row number and the column number. So if I wanted to grab number 2, it's in the first row, so 0, and then it's the second item. So you put 1, and it'll give you 2. So you can use either of these 2 ways to index. I think I generally use this way, but either way works. So always start, it's your row first, then your column number, and everything always starts at 0. So it's like 1 minus what you think it is. If you want to select a row, you call that row number and use this colon. So basically how you read this is you want this row and all the columns. So if I wanted the first row, I would put 0. I want the 0th row and all the columns. And it would output this. And it's the same idea for columns. So does anyone have any idea how you would select a single column? Yeah. Yeah. So we would do array, our brackets, then a colon, because we want all the rows, but we want whatever column number. So if I wanted the second column, I would do array, brackets, colon, all the rows, but I want the first row number 1, or column number 1, which is the second column. And then if I wanted everything after the first row or after some row, you would do that row and then the colon. So it's very similar in lists where you take the starting value and then your colon, meaning you're starting at that value and you're taking everything afterwards. So for this one, I want everything after the first row. So I want to start here. So I want row number 1 and everything after that. So I want this row and everything after. The colon basically means like everything after or all of it. Okay, I don't think we have time to go over these ones, but if you wanted to, I'll upload the solutions to the demo, and this is on the demo, so you guys can look at it at your own time. But these are pretty important to look at. If you wanted to get the last 2 columns, it's a very similar idea. And if you wanted every other row or every other column, it's a very similar idea to how you would get every other value in a list. Okay, here are some useful functions that you will need for sure. The first one is np.max. If you pass in an array, it outputs the maximum or the biggest number or biggest value in that array. Similarly for min, it'll output the smallest value. np.sum, which we just used, will sum all the numbers in an array. These last 3 you will use a lot. np.ones gives you a array of ones with the length that you provide. So num values. So if I wanted an array of 1s with length 10, we do np.ones parentheses 10. Same thing for zeros. np.zeros, same idea, except it outputs an array of zeros. And then the last one, np.random returns an array of random numbers of the length you provide. This one's useful in like certain contexts. Maybe not so much in this class, but those last 3 like I use often in my data science courses. So if you ever take any courses like that, you might use these. I know there's so much to NumPy. We didn't get to that much, but you learn as you do problems. NumPy is definitely one of the concepts in Python where you actually have to do problems in order to really get it. So on Monday, we'll have a discussion on this and it'll hopefully make a lot more sense. Thank you guys.